Hi friends, Miss Cedarquist here. Today we're going to talk about graphing linear equations using standard form. Our language acquisition objective is to explain how to write and graph linear equations in standard form using academic vocabulary. And our central question is, what information does the standard form of a linear equation reveal about a line? This page of notes is going to go on page 15. It is 2-3. Let's first talk about standard form. So when we've talked about point-slope form, we've talked about slope-intercept form, and the final form that we're going to talk about is standard form, which is ax plus by equals c, where a, b, and c are just numbers. They're just integers. They're not fractions. They are whole numbers, okay? And we graph standard form by using intercepts. So intercepts are things that fall on the y and x-axis, and these guys right here where the arrows are pointing, those are intercepts. So y-intercept is when x is 0. So you have a point 0, comma, whatever that guy is. And an x-intercept is when y is 0. So we have something, comma, 0, okay? And all we do is we just put the points on the axes, and then that's it. That's all we got to do for graphing standard form. So let's go straight into the examples. Use the x and y intercepts of the equation to graph the line. So I get negative 2x plus 6y equals 12. So I broke this up into two different parts. So the first part we're going to do is make y 0. When we make y 0, I'm going to put my finger, I know you guys can't see it, but I'm going to put my finger over this 2x. So I don't have that anymore, and I'm left with, I'll just do it down here, 6y equals 12. Because anything times 0 is 0, and it goes away, that entire 2x. It's gone. Bye-bye. See you later, okay? So I'm left with 6y equals 12. Now I just need to get y by itself, so I'm going to do the opposite of multiplication, because 6y means 6 times y, and that's division, so I'm going to divide both sides by 6, and 12 divided by 6 equals 2. So right here is 2. Okay, so then the next part I'm going to do is go to my graph, and on the x-axis, because I just found the x-intercept, so this was the x-axis, I'm going to go 1, 2, 1, 2, and I'm going to put a point at 2, because that's what I got. Now I'm going to change colors so you guys don't get confused. So the y-intercept is when we make x equal 0. So I'm going to put 0 in for x. Now the 6y is going to go away. So I am left with negative 2x equals 12. And then I undo multiplication by dividing. So I'm going to divide both sides by negative 2. And I get x equals negative 6. So now I go on the y-axis at negative 6. So negative 1, negative 2, negative 3, negative 4. Oops, I need to make this bigger. Negative 5, negative 6. Put a point right here. And then all I gotta do is play a game of connect the dots. Use purple. And I'm gonna connect the blue and the red dot. And that's it. We graphed the line. Okay, let's do B together. One more. All right, so B, 3x minus 2y equals 9. First thing I'm gonna do is make y equals 0, which gets rid of this 2y. This goes away. Okay, so I'm actually left with 3x equals 9. And now I just need to get x by itself. So I'm going to divide both sides by 3, and I get x equals 3. Then let's come over to the x-axis and plot 3. So here's 1, here's 2, here's 3. Put a point at 3. Okay. Now we have to do our y-intercept. So our y-intercept is when x is 0. So now this 3x goes away, and I'm left with negative 2y equals 9. Now I need to divide everything by negative 2. A positive divided by a negative is a negative, and 9 divided by 2 I think is 4.5. So my y-intercept is at negative 4.5. So here's negative 1, here's negative 2, here's negative 3, negative 4, and -5, and -4.5 is in between that. So right there in the middle-ish somewhere. And now I just have to connect my blue and red dot. And there I go. Okay, so C and D, those are triads. I also need to do a question and connection for this chunk. I know that the tables look a little different. All you're going to do is plug in 0 for x and then 0 for y. Excuse me, 0 for x and 0 for y. And then you're going to do the same thing as up top, just it's one table instead of two, okay? But I want you guys to try it. The graph for C comes down here. The graph for D goes down there, okay? Try it and then do the chunk summary on the back, and I will meet you for the second example. Okay, so you should have tried at least chunk summary number 1. Fill in the blanks with what you can. Let's do example number 2. What does the graph of ax plus by equals c look like when a equals 0? So if you look at this first guy, there is no ax term. That guy's missing. So we are left with by equals c. That's what we're left with. So what we're going to do is we're going to get y by itself. I divide by 2, and I get y equals 3. So that's a line. I know it looks like it's not, but it's a line. It's not a point. So I'm going to go to the y-axis at 3. 1, 2, 3. I'm going to put a point there. Now, whenever a equals 0, ladies and gentlemen, you are always going to have a horizontal line. So this is horizontal. And this is also when there's a 0 slope. There is no slope to this, meaning if I'm going on the treadmill, I am not making it go uphill or downhill. I'm going straight. There's no slope. It's a 0 slope, okay? So whenever a equals 0, the line is horizontal and has a 0 slope. Okay. Now let's talk about what does the graph of ax plus by equals c look like when b equals 0, meaning there is no by this time. So I'm going to divide by 3 for this problem. This 3x equals -6 on both sides, so I can get x by itself. And I have x equals, and -6 divided by 3 is -2. So I'm going to go to -2 on the x-axis. Here's -2, here's -1, put a point. Now remember, this is a line, and if this first line was horizontal, then this line is vertical. So whenever b equals 0, it is vertical. And in case you get asked, vertical lines have undefined slopes because no one is walking up buildings like this. So if you can't walk straight up and down like this without special shoes or special abilities, then it's undefined, okay? 0 slope is definitely something that you guys can walk. So now what I want you guys to do is I want you to try A and I want you to try B. And then chunk summary number 2. And then question or connection. So even connecting my real life example that I talked to you guys about horizontal lines being something that you can walk and vertical lines being something that you can't, that's a connection to your real life. And then I will meet you on the back. Wow, these notes flew by. Okay, so this is going to be probably the hardest example of the notes. We need to write the equation in standard form, ax plus by equals c. So we've got stuff from slope-intercept form, we got problems in point-slope form, and our goal is to get to standard form. And also remember, a and b are whole numbers, so no fractions. No fractions allowed. Okay, so I'm going to do a and b. The way that we're going to do this is first we need to move this x term. We need to move this guy over here. And in order to move this, we need to use addition or subtraction. So I'm actually going to subtract because that's a positive 1 over 6. I'm going to subtract 1 over 6x on either side. Minus 1 over 6x. And I get negative 1 over 6x plus y equals 3. Now there's a fraction there, and I literally just said no fractions, right? So I need to get rid of the 6. Well, lucky for us, Missy has taught you guys how to clear a fraction. And we clear a fraction by multiplying by the denominator. So we're going to multiply everything on both sides by 6, and then we're done. So these 6's will cancel, and we get negative 1 times x, so negative 1x. And then 6 times y, so plus 6y, equals 3 times 6, which is 18. And that right there, my friends, is standard form. All done. All right, let's do B. Y plus 1 equals 3 over 2x plus 1 again. So this is point slope form. Now we need to first convert to slope intercept form, then go to standard form. So I have to first distribute. This should be review. We did this in the first page of notes. So I'm going to distribute first. So I'm going to have y plus 1 equals 3 over 2 times x is 3 over 2x. And then 3 over 2 times negative 1 is negative 3 over 2. Now I need to subtract 1 from either side. Now if I have trouble combining these two together, which you might, this negative 3 over 2 is the same as negative 1.5 minus 1. So if I owe you $1.50, so negative 1.5 minus 1. If I owe you $1.50 and I owe you another dollar, I actually owe you negative 2.5. I owe you $2.50, correct? Okay, which is the same as, just because we're going to have to clear that fraction, I'm going to keep it as a fraction, which is the same as negative 2.5. If you're using my calculator, I will show you in class how to keep the fractions so you guys don't have to convert to decimals, but the fractions are important here, okay? Which, again, keeping into a mixed fraction, 2 times 2 is 4, so this would be negative 5 over 2. Okay. So, going into that, we're going to have y equals 3/2 x minus 5 over 2. And now I need to move this 3/2, so that's positive, so I'm going to subtract it. So 3/2 x minus 3/2 x, because I want my x and y to be on the same side. I'm running out of room, so I'm going to write it over here. Negative 3/2 x plus y equals negative 5/2. Now I need to clear the fraction. That's why I kept it as a mixed fraction, so it would be easier. So I'm going to multiply by my denominator, which in this case is 2, on both sides. These 2's are going to cancel, and I'm going to be left with negative 5. And then these 2's are going to cancel, and I'm going to be left with negative 3x. And 2 times y plus 2y. And that's it, right there. All right, so I want you to take a crack at C and D. Try it. We will do 2 and 3 in class tomorrow, and I will see you tomorrow. Bye.